This is section 2.4, and we're going to talk about modeling with functions. Now, to model a function means you're going to take some data, usually in a word problem or a chart, and you're going to try to create an equation that models that. All right? So for a linear function, to model a quantity changing at a constant rate, so that's mx plus b, then you want to think about f of x equals the constant rate of change times x plus the initial amount. Or this is the same as the slope, and this is your y-intercept, the initial amount. So let's look at that in a problem. All right, this one has two problems for us, and they want us to write a linear function and choose a name for the variable, etc., and state what the input variable represents and what's the domain. Well, right now what I want you to look at is, let's see if we can create the model. All right, so in A, little dots here. In 2011, the average cost of attending a public college was $8,200, and it's projected to increase on average by $600 per year after 2014. All right, so we're talking about starting at 2011. So what's the cost at the start? $8,200. That is the initial cost at 2011. All right, then we're told it's increasing $600 per year. That's a rate. Okay, so 600 is a rate of change per year. All right, now let's talk about what we could call the variable. Let's let x be the number of years after 2011. All right, and we're trying to find what the cost is going to be, the average cost at some other year. Okay, so let's call that C of x. That's the cost is going to be, it's going to change $600 every year. So 600x plus, we already have that initial cost that was there in 2011. And so that would be modeling what we're told in that paragraph. All right, let's look at B. All right, in B, a car's speed is 50 miles per hour, and it begins to slow down at a constant rate of 10 miles per hour each second. All right, so we're talking about speed. So if we call it S of x, and why do I have 10 miles per hour is how it's slowing, and it started at 50. Why do I have negative? Because in our data, we're told it's decreasing, slowing down. That's a decrease. So we're going to have a negative slope. So it would be S of x equals negative 10x plus 50. All right, let's look at another example. We have a 100-gallon tank, and it's initially full of water. It's being drained at a rate of 5 gallons per minute. So we need to do a few things. It's often helpful to draw a picture. Not totally important here, but I like to draw and use my little markers on the screen. So I've got our tank, and it is up to the brim, and it's being drained. So 100 is our initial amount. That's how much water is in here to start with. So we have 100 gallons to start with. 5 gallons per minute is a decrease. It's draining out at 5 gallons per minute. So we could say f of x is equal to negative 5x plus 100. That's our function. All right, so that was A part. Write a formula for the function. B part, how much water is in the tank after 4 minutes? This is why it's wonderful to be able to model, because then you can answer other questions. If we have the function and we say, okay, if x is the number of minutes, which we should have written here, so f of 4 means we plug in 4 for x. Negative 5 times 4 is negative 20 plus 100, so 80 gallons. That means after 4 minutes, 20 gallons went out, we now have 80. C part says graph that. And so we're graphing, and you could do that in your calculator, which is what I used here, and I put in negative 5x plus 100. Now to see that, you're going to have to definitely change your y max up to at least 100 or maybe 120 so that you can see it. And it says identify the x and y intercepts, which you can do with your calculator. And so the y-intercept right there is 100 and the x-intercept is 20. And C part says graph f, we did that, discuss the domain. Discuss the domain. All right, before we do that, this is about those intercepts. And so the y-intercept, what does that actually mean? That's what it held initially. Remember, that was the amount of water in initially. That's going to be your y-intercept. The slope is negative 5. Water's leaving at 5 gallons per minute. And x-intercept, the tank is empty after 20 minutes because time in minutes is down here. All right, so that's what those mean. The domain, as you can see here, x exists between 0 and 20. And that's how you would do that. And the tank can at most hold 100 gallons. So that's an important note. All right, then we're going to learn a little bit about a couple of other functions. And the first one is called the piecewise function. It is literally made up of pieces. And you'll see it with a brace here. And here's a piece. It's x minus 1 for everywhere that x is greater than 2. It's the line negative 2x if x is less than or equal to 2. All right, we're going to do these in our calculator. You could do them by hand, but we can do them in our calculator. You want to put them in 2 lines. So in y1, we're going to put this part in parentheses, x minus 1, and the parameter in parentheses, x greater than 2. We're going to do the same thing for y2. And where do you find these inequality symbols? Second math. All right. Also note that over here, I've got these written as little dots. That's because we want to be in dot mode. We don't want to connect unless we're literally connected. And so to keep that from connecting here, we'll put it in dot mode. All right, so here's your directions, and we would put that in. And you would get a picture like this. And here is at x equals 2 is where it's different. If you note, we've got right here, this is at x equals 2. So for everything greater than 2, it's x minus 1. It's this line. For everything to the left of 2, it's negative 2x. And this one had an equals under it, so it gets a closed circle. This one had an open circle. And we'll practice these in the homework, but I wanted to just go over what they are right now. The other one that we might see is called a greatest integer function. And it usually in the book or on MathLab, it might have 2 brackets like that. And so what it means is the greatest integer value of x means the greatest integer under x. So if x is 3.5, the greatest integer, integers are whole numbers, under that would be 3. If it was 4.7, it would be 4, 3.8 would be 3, 7.5 would be 7. So it's called also a step function. If you put it in the calculator, you're going to go to y1, and you still want to be in dot mode, and it's int x. You can find that 2 different ways. For one, you can go second, the 0 key, and hit the x squared key, which takes you down to the i's. or probably the easiest way, and the one I would suggest, would be math, over to number, and choose int. So we'll be using both of those new kinds of functions in our homework, and let's go look at that and see what we've got. All right, so let me make this a little bigger. All right, so the first question says complete the following for this. And the first part, you don't have to graph it. We can do the evaluation without graphing it. This will be for this last part, this C part. So the first thing says, what's the domain? All right, well, you look at your parameters right here. So what's the far left on the x that we have? -6. And the far right that we have is +2. So our domain would exist from -6 to +2. All right? So that's that first part. The second part here, evaluate f of -5. Remember that we're plugging in -5 somewhere. We have to figure out whether it falls in between these two numbers or between these two numbers. -5 does not fall here because it's on this side of -2. So it falls here. So our answer, oh, there's no x to plug into, so our answer would be just 0. All right. F of 0, where does 0 fall? Where does 0 fall? Well, where this is between -6 and -2, you don't hit 0. -2 to +2, it falls here. So we plug in to this piece. So we would have 0 plus 2, which equals 2. So f of 0 would be 2. We're also asked to do f of 1. Looking here, where does 1 fall? It also falls here. So we're going to plug into the x plus 2. So we have 1 plus 2, which equals 3. So you want to look at the parameter, find which place that number falls, and then plug it in, if there's an x to plug in, right there. All right, now we're supposed to choose the correct graph. All right, now here's where I've put how you would need to put it in your calculator. All right, so I will do this one for you. Let me get my calculator open. While it's opening, just remember the few things that we talked about. You have to put it in dot mode. You have to put everything in parentheses. And let's see. We'll go here, clear all of that. And so the only thing that we didn't talk about already, this is called a compound inequality. It's got x between two numbers. And that wasn't what we saw in the lecture notes, so you have to do it a little bit differently. You want to take this part and make it one parentheses, -6 less than or equal to x. Then you want to take this part, x less than or equal to -2. And you want to do that for both of these so that you have 3 parentheses there. So if we were here, we would go up here, and in the first parentheses we would put the actual equation, which we just have 0. Open another set, we'd have -6. We'd go to second math, make sure this is down, and we would have less than or equal to, so that'd be 6 is less than or equal to x, close, open, x, second math, is less than or equal to -2. All right, come down to y2, and we're going to have parentheses, x plus 2, open, -2, second math, we just want less than, which is number 5, x, close, open, x is less than or equal to, so we'll go to second math, number 6, 2, close. I've got dot mode on both of those, so let's do a zoom 6 and see what we get. Okay, I didn't get my second one. Let's see. Oh, yeah, because it's y equals 0. And y equals 0 is the x-axis, so it's not going to show. So we are looking for something like that. Let's look at our choices here. Let's see. I think I have it here. Okay. So the difference between these two, this one has a open circle here, and let's look at what our things were. They all had, this one for the 0 had equals on both of them, so it's going to have a closed circle on both ends right here. So that's the one that we're going to choose. All right, let's see. You would do the same thing on this one. It's got 3 pieces. I've written it out here, how you should put those in. Again, you've got the compound inequalities, so you have to break them into this part and this part. And you have them all here. Remember that fractions go into a little parenthesis of its own, so you have lots of parentheses there. If you do that all and you graph it, you should get this one. You have to be careful because this one looks like this one. The difference is the open circles and closed circles. So you want to be sure and look at where the equals are on this particular one. We're going to have closed on both. This one has an open and a closed and an open and a closed. So you'll just have to look at that and practice with that. You would also want to change your window so that your x-min was at -7, your x-max was at 5, your y-max was at 10, and there you're at -2. That way you can get this exact window. All right. All right, for this one, it's just evaluating. We don't have to graph. So we're just checking. -5, where does -5 fall? Okay, here's our parameters that we need to look at. -5 is less than -3. So we're going to plug it into this part. So we have -4 times -5 minus 12. That's a positive 20 minus 12, so this is going to be 8. All right. -1, and that's, I don't have a negative there. Where does -1 fall? -1 falls here. So there's nothing to plug into, so that's just going to be 5. Because it says for all numbers that fall in this area, it's going to be the horizontal line, 5. +5, well, that's this parameter. So this will be 5 plus 1, which is 6. And 9 is also in this parameter, so this would be 9 plus 1 equals 10. Right? All right, we're going to use dot mode to graph the function f and then evaluate 2 things. So I'm going to do this one with you. Let's go to y equals. We'll clear out both of these. All right, so if we went to math and over to number, I don't have that number written there. Let me put that right now so that we have that math, number, and then number 5. All right, and so we'll choose 5. So we've got the greatest integer value of -3x plus 1, close. All right, and it is, we've got it in dot mode, so let's make sure that we've got everything we need. Yeah, and we're going to graph. Right, now we can't see that really closely, but let me make this a zoom 4. I think we can still see what we need. All right, so you can see steps. You can see little steps. Okay, so mine did not initially look like these, and what I have written here that is really important for you is to be sure that you look at the window that you are given. So when they need you to look at it in a specific window, that's important. And here's your X max, X min, X max, the X scale, Y min, Y max, Y scale. And if you'll put those in, then when you hit graph, you do get a picture that looks like C. All right? So be sure you look for that. Now it says, what's f of negative 2.7? We can just go second, calc, and value. We want value, so we hit enter, and we put in negative 2.7 and enter. Oh, I'm outside the window. I am outside the window. All right, so we can go to second table and put in negative 2.7, enter, and you get 9. So if it's outside the window that you've created, you can go to your table and do it as well. So this one's going to be 9, and then 1.4, as long as we're here, we can just do 1.4 there, and we get negative 4. So use your table for that. Number 5, same thing. To graph the function greatest integer value of x, close that minus 1.0. So you would do the same thing. Here is the window. So be sure that you're using that window. X min, X max, and X scale. You would get B. And then you could do the same thing with the table. And you should get 0 for this one and 0 for that one. Okay? All right. Now, the last one is kind of a long problem, so let's kind of work on this together. This is linear regression, and this is the ring size for a finger with circumference x in centimeters. So here's your circumference of different things, and here is the size that that would equate to. We want to find a function that models the data. We're going to let the calculator do that for us. You have some regression notes in handouts, so I would have that out for me as I started to do this. But we're going to do it together right now. So let me quit out of this. The first thing you want to do if you're going to do regression is go to y equals, clear out anything that's there, jump up and hit enter on plot 1. That turns it on. Then we'll go to stat and we'll hit edit. We're going to put, oh, actually I have them there, great. We're going to put our x values, that's going to be our L1, and our y values will be in L2. So you will put those in there. Then after you got them in and you know what you're supposed to have, you do a zoom 9. You should get this picture here. All right, so we want to use linear regression to determine the equation of best fit. So we're going to go back to stat. Over to calc. And we're going to choose, whoa, that was weird. We're going to choose linear regression, number 4. All right, so we've got that there. Now, we want to tell the calculator, take what's in L1, L2, and put it in Y1. And so this is all on your sheet of the process, but we're going to do second and the 1 key. That gives me L1. I'm going to put a comma. Then I'm going to do second and the 2 key. That gives me L2. I'm going to add another comma. So right now I'm saying take that data in those two places and I want to put it in Y1. So to get the Y1, you go to vars key, which is for variables, over to the Y variables, enter on function, enter on Y1. So we have told it, figure out a linear equation from using L1 and L2 and go put it in Y1 for me. So we can go ahead and hit enter. All right. You may or may not have this r squared and r. It's okay. It doesn't matter. You don't need that. But what you do need is the a and the b parts. And here's y equals ax plus b. That should give us a linear equation. The nice thing is you do not have to type that over, and you're just going to go to y equals and put it in, and it'll be there. So let's go to y equals, and bam, we got it there. So we can just hit graph now, and we have our graph. So I've put all of those screens down here for you. All the different screens that you just saw on my calculator are printed on the lecture notes. So we just went and we looked here. Now, there's the last part of the question. It says, so you have this is your equation. It said round to 3 decimal places, okay? So that's what that is. Now, the circumference of a finger with a ring size of 6. Well, a ring size of 6, that goes down here. That's a y value. So when you go to your calculator, you go back to y equals, and on y2, we're going to put 6. So now let's graph that. All right, so here's our function. This is the size. Here is that. We're finding out where do these two intersect. All right, so second calc, number 5 is intersect, and hit enter 3 times. All right, 5.26, it says round to 2, so that'll be 5.27 will be our answer. And again, all of that, the screens are there on your lecture notes. So that should help you with number 6 in your homework and should get you through 2.4.